right, did we start these notes at all yesterday?
No.
Okay, well I'm going to talk about this stuff really quick, okay? We're going to start solving systems of equations, meaning there's more than one variable, okay? Now, there are different ways to solve systems of equations. There's graphically, linear combination, substitution, and then determinants. Today we're going to talk about graphically, okay? Now, you're welcome. Before we do that, we need to know this. We're going to use the Inspire, okay, to solve this graphically. All right. Does everybody have the notes I passed out yesterday? These. That's what I'm following. There's notes that I passed out yesterday. If you don't have those, make sure you get some. You don't have them? Who raise your hand so I can pass it back? 1, 2, 3, 4. You pass those back, please. Grab one if you don't have them. Okay, graphically is really, really hard to do because you can't tell the answer by just eyeballing it after you graph it. Because there's mistakes by the human hand. That's why we use the graphic calculator to solve graphically. Okay? Now, I'm going to skip this page because I inserted this page that I think is a little bit easier to understand. This page says the same thing that the other page does. Okay, we're going to start up here. Now, you don't have this page in your notes because I added it. So, give me the extras. All right, when you classify systems of equations, when I say system of equation, I just mean 2 equations or 3 equations or 4 equations or whatever you have. Okay, you're going to get 2 different possibilities to start. You're either going to get a consistent system or an inconsistent system. What do I mean when I say inconsistent system or consistent system? A consistent system just means there's at least one solution. At least one solution. An inconsistent system means there's no solution at all. Okay? No solution at all. So you're going to either have a solution or no solution. They're just, instead of saying no solution, solution, they give them actual words. They give them consistent and inconsistent. Okay? Now, if you have a consistent system, there's 2 different options. You can either have an independent solution or a system, or a dependent solution or system. Now, you might say, well, what do you mean? What I mean is this. Pretend that you guys know how you have a fruit. Like, let's say, for instance, apples. And then you have a Granny Smith apple and you have a Red Delicious apple. Correct? You have 2 different kinds of apples, but they're both apples, right? That's the same thing as here. Pretend this is an apple. Okay? And this is my Red Delicious apple. And this is my Granny Smith apple. Right? If I say Granny Smith, does that mean it's not an apple? No, it's still an apple, right? This is the same thing when I classify. If I say consistent, it either has to be a Granny Smith or a Red Delicious. Meaning it either has to be independent or dependent. You do not have to say, oh, that's a consistent dependent solution. That's like saying, oh, that's a Granny Smith, but it's also an apple. Well, duh, Granny Smith is an apple. Okay? You say dependent, that automatically says consistent. Okay? You might say, okay, what is the difference between independent and dependent? Independent has only one solution. Dependent has an infinite number of solutions, and many solutions as you can find. You can't even think of all the solutions because it just never ends. You'd be thinking for the rest of your life. Okay? It just means it goes on and on forever. That's the difference between independent and dependent. Now, you might be still confused, but we're going to go through and we're going to look at each one of these solutions so that you can picture what they look like. Now, the next sentence, graphs for inconsistent systems are parallel lines. What do we know about parallel lines? What do you know about parallel lines? The equations of parallel lines. They have same slope, so their m is the same. And what do I know about their y-intercepts? They're what? No, they don't have to be 0.
They start on 0 or something.
No. If parallel lines have the same slope but different y-intercepts. Yes. Okay, different. Or the b's are different. Different y-intercepts are different b's. For dependent systems, the two equations represent the same line, meaning it's the same equation. Okay? And you're going to see that when we do with these three examples. We're going to get all three of them so you can see what all three of them look like. Okay, so how do we find out what this looks like? Well, first we have to solve it for y. So we have y equals mx plus b form. We can't compare these if they're not solved for y because they're different. So let's solve them all for y. Take the first equation, 4y minus 2x equals 6. Make sure you're following along. You're going to need these equations in just a minute. No, not add 2x.
Yeah, that's all right.
Add 2x to both sides. So I have 4y equals 2x plus 6. Question? Okay. I'm just solving for y. Now what? Divide both sides by 4. So y equals 2 over 4 is just 1/2 x plus 3 over 2. I just reduced that fraction. 3 over 2 is the same thing as 6 over 4. I just divided both by 2. So there's my first equation, y equals mx plus b, where m is 1/2, b is 3 over 2. Right? Now I need to do the other one. What? 8y equals 4x minus 12. How do I solve this one? Yeah, go ahead.
How do you get 6 for
I divided everything by 4. 4y divided.
whatever you added the 2?
I had 2x plus 6 right here. I can't add them together because one's an x, one's just a various number. You can't add things that aren't like terms. Does that make sense? Only like terms you can add together. Now, how do I solve this one for y? Mark? What? Yeah, divide both sides by 8. Good. So I have y equals 4 over 8 reduced to 2. 1/2 x 12 over 8. 3 over 2. So now I have my two equations in slope-intercept form. Any questions before I move on? How I got those? Okay. Look at them. What do I know about the slopes? They're the same. What do I notice about the y-intercepts? They're different. One's positive 1/2. Or 1.5, excuse me, and the other one's the negative 1.5. So I have different y-intercepts, same slope. What kind of lines do I have? Parallel lines, meaning an inconsistent system. Good. This is an inconsistent system.
Wait, how do you have no? And you have no point. How?
They're parallel. They're never going to hit each other. Like this. Look. I have examples. Look. This inconsistent system right here, their lines are parallel. They're just going to go on and on forever. They're never going to hit each other. The only solution is if they hit each other. Okay? Now, let's do the next one. Let's figure out what kind this one is. So I have 2x plus 3y equals 1. Subtract 2x. I'm left with 3y equals negative 2x plus 1. Divide by 3. I'm flying through this. So I'll stop here in a minute. All right, let's go to the next equation. 4x plus y equals negative 3. Subtract 4x. I'm left with y equals negative 4x minus 3. Well, now it's already solved for y. I don't have to divide by anything. There are my two equations. Y equals mx plus b, y equals mx plus b. Now we have to look at those two equations. What do I notice about the slope? They're different. The y-intercepts? Different. So what kind of answer? They're going to be two completely different lines. So what kind of answer am I going to get? This one, this one? Yeah, independent. Because they're going to be two different lines, they're going to cross at one spot and one spot only. So we say this is an independent system. Now let's go to the last one. You can probably guess that it's going to be, I did all three, it's going to be dependent. But let's solve it so we can figure out what they look like. Okay, do we have a question? Anybody? Because they're just two different lines. They're not the same at all. Okay? They're going to cross at one spot. They're not parallel, and they're not the same line. Now, let's do this one. Well, look at that. Y equals 2x minus 3. I don't have to do anything to solve for y for that one. Sweet. Now, let's do the next one. 6x minus 3y equals 9. Subtract 6x. So I have negative 3y equals negative 6x plus 9. Now divide by negative 3. Y equals negative 6 divided by negative 3 is positive 2. And I have x. Plus 9 divided by negative 3 is actually minus 3. Now I have my two equations. Look at your equations. What do you notice? They're exactly the same, aren't they? So if you have the same line, what kind of system do you have? Dependent system. You guys see what they look like? Those are the only possibilities. Inconsistent, independent, and dependent. Now you've seen an example of all three. Now you know what, when you solve for y, what they're going to look like. You're either going to have parallel lines with the same slope, different y-intercepts. You're going to have two completely different lines, or you're going to have the exact same lines. That's it. Okay? Now, we need to be able to solve, if it is one of these three, we need to be able to graph them and see what they look like. Okay, so everybody log on to your calculator.
It doesn't make sense because it's just like
I am following along with the next page of your notes. So keep that out, that way when you do it on your own, you can see, oh, Mrs. Numbers just followed to the next page, where it gives you the steps for graphing. That's what I'm going to do. Okay, so you're going to go to your home screen, add a new document.
don't just save unsaved.
No, don't save the unsaved. Don't save it. If they didn't save it, then
to add?
you want to go to one new document, and I want you to add a graph. Okay, I'm just following along with what you're doing. Yes, ma'am. Right. We can't get in anymore. Set number 18. That thing is committed.
Did I change the batteries today?
I don't know. You're going to do something for yesterday.
Yeah, I think you did.
That was working. Change another time.
All right. Here we go. Here's what I want you to do. For the first inconsistent answer, those two equations, we're going to plug those in for f1 of x and f2. So the first one should say 1/2 x plus 3/2. So type that in, Sky.
Which one?
The ones we just did.
Oh.
1/2 x plus 3/2. And then f of 2 should say 1/2 x minus 3/2.
And you hate fraction.
Control divide. You want fraction, control divide.
You press enter after the first one.
What's that?
Press enter after the first one.
Yeah, you can push tab or enter.
And then how do you get on the other one?
Scroll down.
Okay. This one.
X, good. Plus 3/2 and minus 3/2. I forget which one's which.
The other one?
It's not spelling.
Oh, click on the arrows.
What arrow?
How you
many do we have?
how you go down to the next one? This numbers, how you go to the next one?
Tab. Oh, you got it. If you get to the point where your entry line disappears, all you gotta do is click on those little arrows down in the bottom left-hand corner. Now f of 2, now put the other one in. 1/2 x minus 3 over 2.
Oh, mine did a graph thing.
Hey, what do you get? 2 lines, what are they? Parallel. That's what inconsistent graphs look like. Parallel lines. So when you graph it and it looks like this, and you can see the slope's the same but different y-intercepts, those are parallel. Okay? Anybody not here?
Yeah, mine didn't do that.
What did you do?
It says graph with a question mark. Like I'm all the way at the end on the top row.
Where's escape? Okay, now go to arrow down right here. Okay, click down here into this. Now,
I
you should
did
be
all
at F2.
Alright, I'll do this again. Let's see if it works.
Make sure you push tab if you want it to enter in. Sometimes it doesn't work. Oh, 3 over 2.
Wait. So, like, almost works.
Put arrow up. Okay, erase the last fraction and put minus 3 over 2. Or either that or just go in and fix those. There you go. Put minus 3 over 2. Okay, enter. Or tab. There, now fixed it. Okay? There, that's what you should look like. Everybody with me there? I can see if you are not. Parallel lines all the way around. Good. Oh, Sierra. Oh, you just did it. There we go. All right. Where are you, Sky? All right, let's go do the next one. So add a page. Control doc. Graph page. Now you're going to put for f of 3 and f of 4 the next two equations. I don't have them up here because they're on my smartboard, but I don't remember what they are. Y equals negative 2/3 x plus 1/3.
Yeah.
Y equals negative 4x minus 3. So you should have them on your notes so you can look at them. Put those in there. You forgot an X in your graph there, Scott. So it's not going to graph. Go up to f of 3, arrow up. Just push arrow up. There you go. Put an X in there. Good. Now. Oh, you didn't push tab. X and then push tab. There you go. Now go to f of 4. Did you put them in the wrong? No? Oh. Here they are. These are not graded, right?
Yeah, I like the ones that are.
Okay. Everybody have this? Good. You see how the graph looks like when they're two completely different lines? We see one intersection. We need to figure out what that intersection is. So here's what we do. I'm following along with that step. You're going to go to menu. Analyze graph. Intersection. Now, before you do anything, it says, okay, where do you want me to find an intersection? That's what the calculator is asking you. So you want to pick to the left, the lower bound, the left X. So you're going to push click, and once it switches to upper bound, go ahead and click to the left of the point. Now upper bound, now go over here to the right of your intersection. and click there. And what's the solution?
-1.
-1, 1.
Wait,
See,
what do I
that's
I missed the
Who
flow.
doesn't have a solution?
Yeah, that one. You know?
A lot of you have the wrong graphs in there, don't you?
It's telling me I don't have an intersection found.
Well, then you. All right, Aaron. Okay. Well, okay. Go to menu.
Do all this again.
Analyze graph. Intersection. Now you have to pick a lower bound to the left.
Says no.
Click, and then once it switches to up, no, go way over, so it doesn't have to think about it. Okay, right there. Don't make it wonder. Click until it switches to upper bound.
No, I did that.
Okay, don't hold click. You're just either that or push enter. Now just push enter. Okay.
Now to restart again.
Yep, but you have to be real careful. You want to do one click until it switches to upper bound, then go to the right and click once really carefully. Now push, now go to the right. Now click again. Now do you see where you have your intersection there? -1, 1.
Okay.
There's your solution. That when it asks for a solution, you would say x is -1, y is 1. Now we have one more set of equations to enter, a dependent. So go add a page. Control doc, graph page. For f of 5 and f of 6, enter those two equations in, which are the same, aren't they? 2x minus 3 and 2x minus 3.
Then you hit tab, right?
Yep, tab until it goes down to the next one. Oh, you're at 7. Go up 1. There you go. 2x. You might have to click in there. There you go. 2x minus 3. Then push tab. And I'll push enter. There you go. You got them both. Look, you see how they're kind of smushed on top of each other? Take your hand and go close your hand over one of those equations. Go on the equation, not the line. The equation. So it turns into a hand. Or click on it. You're clicking on the graph right now.
What do you mean?
Wait, you need a hand. Take your hand.
No, I lost my whole...
We'll find it. Okay. I don't want... There you go. Right now you're selecting the equation. You see how this is bold?
Yeah.
You don't want that to be bold, so push escape. Now, go take your cursor until it turns into a hand over your equation. Okay, now click and hold. Now move it. You see how there's two?
Yeah.
Okay, now push enter. Now, you have two equations. Look, it's the same line. No matter what point you pick for one equation, it's going to work for the other because it's the same equation. That's what the solution looks like for a dependent solution on a graph. Any questions? Do you see all three? Okay, your homework is
Nothing.
on page
I wish.
139, okay, 18 through 40 even. Now, listen very closely. There are 4 of them where you need an Inspire calculator. 30, 32, 34, and 36. You have 12 minutes to get started on those. Do those right now. Right this second. Okay? Do those right now, and make sure you save them in the 9 Algebra 2 folder. If you're not listening, I'm going to have to repeat this. 9 Algebra 2 folder under 3-1 space HW. 3-1 space HW. I'm going to collect that tomorrow. If you don't have it and you weren't listening, you don't get the points for it. Okay? You make a new document. Make a completely new document. You don't need to save what we just did. Make a new document. If it asks you to save, say no. Okay? And you're going to save your 4 problems as 3-1 space HW in the 9 Algebra 2 folder. What?
Can be a graph.
How do we get out of all this stuff? Like,